Okay. So let's see if we can figure this one out. We've got a block brake with a lever pinned at A, and we're trying to find what force I have to apply here, P, to prevent this wheel from moving. The problem says determine if the brake can hold if you apply a force of P of 30 newtons or a P of 70 newtons. So probably one is going to be okay, one is not, more than likely. All right, let's start by taking it apart and drawing our free body diagram. I'll start with a free body diagram of the wheel. The wheel has a moment applied of 5 Newton meters about the center, and we know the radius. So at that contact surface, I would have a normal force. I'll call that the normal at B. Now, this wheel is rotating counterclockwise, so the friction force will be opposite of that, and that'll be my friction at B. I think that's all the forces we have. Does the wheel have some weight? It does not seem to have any weight. So we're okay. So only 2 unknowns there. What do I need to do? I think the best thing to do would be to try to sum moments about this point O. So if we sum moments about the center, make sure in equilibrium, what do we have? Well, we have the applied moment, positive 5 Newton meters. Then I have the moment produced by the friction force, which is opposite, and it has a moment arm of the radius, which is 0.15 meters. And then the normal force passes through O. Well, that's nice. That means I can solve for the friction force at B. So it looks like that should be a value of 33.3 newtons. Now our structure is probably at impending motion. So if I know the friction force holding it from moving, I should be able to get the normal force because I know that the friction at B should be equal to the normal at B. So therefore the normal at B should be that friction force at B divided by mu S, which for us is 33.3 newtons, and the friction force at that point is 0.3. So what's my normal force equal to? I got 111.1 newtons. Now, I just realized something. If you sum forces in the x direction, the y direction, it seems like these things would be 0. What I forgot is this thing is pinned here. So really, there's going to be forces in the x and y direction keeping the wheel from moving. Call that point O, so I guess this would be OX and OY. And we don't really care what they are, and they don't affect any of our equations, but I just wanted to put those in there. So you could actually find the pin supports now by balancing it with the normal force for Y and the friction force with X. Yeah, I made a mistake there. Okay, now the next part would be the arm that we have. So we have our force P, and then what happens? Okay, our normal force is equal and opposite. So here's our normal at B. Also notice that the height of the block puts our friction force slightly below the pin. So I'm going to kind of draw it in this upper position, friction force at B. And then up here at the connection at A, let me extend that just a little bit. I'll have my reactions there. So there's my free body diagram for the handle. But remember, we already have the normal force, we already have the friction force. So there's only 3 unknowns. And the question says, what's P? So how can I get P with one equation?
You take the moment at A.
Great idea. So we're going to sum the moments at A, make sure we have it in equilibrium. Okay, start with the friction force. It's going to create positive moment. So I'll have the friction at B. The moment arm is going to be this little distance here, which was 50 millimeters, which was 0.05 meters. The normal force is creating negative moment. And its moment arm is this distance, which is 200 millimeters, which is 0.2 meters. And then the force P about A is creating positive moment. And its moment arm is 200 plus 400 is 600.6 meters. So remember, I know FB. I know in B, I should be able to solve for P. So let's see what that is. So in B is 111 times 0.2. And then FB was 33.3 times 0.05. I got the wrong answer. Let's try that again. So 33.33 times 0.05, that's that. 111.1. What'd you guys get?
34.3.
That's what I got too. Yeah, 30. I got 0.26, but that's close enough. So that's the force required to keep everything right at impending motion. So the question is 30 newtons enough? The answer is no. Is 70 newtons enough? The answer is yes. So for part A, the answer would be no, because P is greater than 30 newtons. And for part B, the answer would be yes, because P is, I got that wrong.
That was right.
It says that P is 30 enough. The answer is no, right, because that should be P is, I did it wrong. So 30 is less than 34.3. So that's why it doesn't work. And it's yes because 70 is greater than 34.3. That sounds a little better. Sorry about the mess. Any questions about that one? Okay.